Let's look at how to measure the rate of reaction and what sort of graph you're going to get. Roll that graphic. Hi, I'm Paul. This is Science That Sticks. In this session, I'm going to talk about the rates of reaction of different reactions. Now, the rate of the reaction is how fast the reaction is. So you will always need a timer. It doesn't matter how you draw a timer. And why would I draw a timer? The reason for this is because if you're going to be asked any questions from a GCSE paper about rates of reaction, and you will be asked questions about rates of reaction, it might ask you about the equipment you need. You're always going to need a timer. You can't measure how fast something is unless you've got a time for it. So you need a timer. But how do you measure the rate of a reaction? Well, it's going to be something divided by the time. Well, what's the something? Well, it could be the production of a product, or it could be the evolution of a gas, which is also the volume of a gas, the production of a product. But you could also measure a mass lost. So which ones of those are going to be the ones that are most easy? Well, if you're doing AQA GCSE, it could be any one of those, including waiting for something to just black out a little black cross. So let's have a look at some common ideas. Let's look at the reaction with marble chips and hydrochloric acid first of all. It's a simple reaction. And we're going to write it up on the board as a word equation. Let's look. So, marble chips are calcium carbonate, react with hydrochloric acid, producing water, carbon dioxide, and calcium chloride. Now, the fact that this produces carbon dioxide means it will fizz. If it fizzes, that means you can capture the gas. How do you capture the gas? It's a couple of ways. The most common way in many schools is to have a delivery tube going into a trough of water with an upturned measuring cylinder and the bubbles move up. Let's draw this simply. So I've got my trough, I've got my conical flask, I've got my what appears to be a straw, but it's actually a delivery tube. It goes over and under here. That's not very well drawn. And then you've got your measuring cylinder that always looks like it's floating. Obviously it will be sat on like a little clay thing which allows air to go inside of it. Then you've got your water level here. The gas will bubble, you'll have a water level here. And you need to make sure that your conical flask here is completely sealed in the delivery tube. The reaction takes place with your calcium carbonate there. There's bubbles. The gas moves up here and then bubbles. You capture the gas, you measure the volume of the gas. So in this case, finding the rate of the reaction will be the volume of the gas produced over time. Really simple method. Another way of doing this is because carbon dioxide is given off and carbon dioxide has mass, that means you will see a reduction in mass. So you can put it on an electronic balance and watch the decrease in mass. So you could draw a diagram. I always recommend that people draw a diagram. You've got some cotton wool here to stop any sort of water spitting out. You've weighed your calcium carbonate, you've weighed your conical flask, you've weighed the amount of acid that's in there. You obviously know the volume, you obviously know the concentration. You're just looking at a mass decrease. So let's say it starts at 500 grams exactly. It won't, it'll be some other random number. And then you time it for 5 minutes. And then what you do is you measure the mass or the mass change over time. Now, in this case, the mass will decrease, which means your graph of time versus mass will come down. In this case, your graph is going to go up. So you've got time and you've got volume of gas here. So it will go up and it will level off. Here, it will also level off. This means that the reaction has finished, kaput, done and dusted. There's more videos that are knocking around on the net that will allow you to see this taking place. I've just done a quick pair of them, which you can see how you would measure the rate of the reaction as a gas being produced, so a product is produced or a product is lost. In this case, it's the same gas, carbon dioxide. There's lots of different ways you can do this. That's the main one for today. As always, stay cool, take care. Good luck with your exams. Bye-bye.